Alright, so we are going to look at solving a system of equations. We're going to use matrices. Okay, so you need to learn what that is first, and we will do that. But this will just build on what we did last time. So last time we used elimination and substitution to solve these. Today we're going to use something called a matrice, and your calculator will be able to help you with this. So it will be kind of convenient. Okay. So all a matrix is it is a system of equations where the variables are removed, all the pluses and minuses are removed. We're just taking the coefficients in front of each variable. So in this case, 5 is in front of x, and 4 is in front of y. Now you do have to make sure that both of your equations are in the same form, that we have our variables all over here, and they're equal to some number over here. So that is important to have them both in the same form, in the same order. And then our answer is over here, that's negative 15. The second equation, again, we're just writing the numbers from this equation. So negative x means the number in front of x is negative 1. Since y doesn't have a number in front of it, it would just be a 1. And then our answer is 12. So we're just kind of lining up the numbers from our equations in here, but we're not taking all the variables and the pluses and minuses and equals. So I guess we have to take the sign of things, so that is important. So what we're going to do now is we're going to actually use your calculator. You'll need a graphing calculator for this. And we're going to solve the system of equations using matrices. So again, a matrice is just the equations with just the numbers, not the other things. So I'm going to get my calculator up here. Alright, so this should look just like your graphing calculator. If you don't have a graphing calculator or you're at home or something, there are matrice sites that have calculators online, so you can check that out. So what we're going to do is we're going to grab an operation. See how here it says matrix? It's blue, so I'm going to hit the second key, and then I'm going to hit that matrix key. And it's going to bring up this little menu. It says names, math, edit, and then it has a list here. Well, we want an operation on our matrices, so we're actually pulling up that operation first before we enter the matrix, so that the matrix will be inside the operation. And what the operation does is it reduces down our matrix and gives us basically a solved equation so that we can see what our solutions are. So let's look at an example. So see how it says down here, I just did the down arrow until I was highlighting this one that says RREF. So what that stands for is reduced row echelon form. And what that's going to do is it's basically going to do some operations on our system of equation that is going to solve for x and y. So we're going to hit enter here so that it brings up our RREF. Now we're going to enter in the matrix. So the way we do that is we're going to hit F3 up here and see how it's green. So we need to hit the green alpha and then the middle key zoom, and that will give us this little row column thing here. It's a matrix. So we need to tell it how many rows our matrix has and how many columns our matrix has. The number of rows is the number of variables, the number of equations that we have. So our system has 2 equations for number 1, right? We have that over here. So we need 2 rows because there's 2 equations. The columns is the number of numbers that come from each of our expressions, or it's the number of variables plus 1. So we have 1, 2, 3 columns, so we're going to put in a 2 by 3 matrix. You can adjust these by pushing the up and down arrows to highlight the ones you want, but since the ones we want are already highlighted, I'm going to hit enter on my calculator. Okay. Now I need to put our numbers from our matrix in here. Again, make sure that x comes first in both equations, the y comes second, and then that the answers come third. So I'm going to enter 5, and then I'm just going to hit 4. Oops. I guess I better do the over arrow first, so I'm going to do that one. So hit the over key once you got that, and then 4, and then over, and negative 15. Make sure when you do the negative 15, you're using this little negative down here, not subtracting here. Just hit the arrow key again, and it'll take you to the next row. I'm going to do a negative 1, and then a 1, and then a 12. So now I've got my numbers entered into the matrix. This RREF, again, it's going to solve our equation for us. It's basically going to use elimination. It's going to tell us what our solution is. Notice there's an open parenthesis over here. I don't know if it will matter if you close it, but let's go ahead and use the extra safe and close it. And then I'm going to hit enter. So now what it's showing me here is another matrix. In the matrix, I have a 1, and then a 0, and then I have a number. In the bottom one, I have a 0, and then a 1, and then a number. So let's look at our equations again. Over here, my equations, I have the x is listed first, and the y is listed second. So because this first row has a 1 in the x column, I guess, or the, so it's in the position of x. This is the same as saying 1x equals negative 7. Okay, it got the y to go away. It eliminated the y, and it reduced the x. So this is like saying x equals negative 7. And then notice the one here is in the y column. So that's like saying 1y equals 5. So we know that x equals negative 7 and y equals 5. So we're going to come back over here and write that down. So x equals negative 7 and y equals 5. Okay, so just like when we did it by hand, we did elimination and substitution, this operation can help us to find that point, xy coordinate, where these two linear equations intersect. Okay, so let's try another one. So my equations are already in the proper form. I've got my x is listed first, my y is listed second, and then my equals some number. So I can go ahead and put these in my calculator. Okay. I'm wondering if I can actually, instead of, well, let's just go through all the steps again because it will be good practice to remember how to do it. So again, you're going to first access this matrix key here by pushing the blue and then matrix. You're going to go over to math, and then you're going to go down until you highlight RREF, and you're going to hit enter. That's going to bring up the operation. That's going to simplify our matrix. Now that we have that operation in there, we need to enter our matrix. So in order to do that, we're going to hit this F3, which is alpha, zoom, so that gives us the F3. Again, I do have a 2x3 matrix again, so I can go ahead and just push OK here. And since OK is highlighted with this little square, that's how I know I can just hit enter. If I needed to adjust it, I just hit up and down and over and all that until I get to the right ones I need. You can hit enter when you get the one you want is highlighted. So now we're back on OK. We're going to hit enter. Now we can enter our matrix. So again, remember, it's just the numbers in front of our variables and then our number that's across the equal sign. So on the top one, I'll have 1, negative 7, and 15 across there. So 1, negative 7. Again, very important to choose this negative, not that one. And then 15. If I just hit the over arrow when I'm done with that first row, it will take me straight to the second row. So then I've got negative 2, 14, and negative 30. Okay. Again, I don't know that you need to close your parenthesis. It probably would work either way because you're not putting anything else besides one matrix in there. And then hit enter, and it will tell me. Okay, so this one looks different, right? This one has all zeros on the bottom, and it has a 1, a negative 7, and a 15. Okay, what this tells me is that it didn't solve the equation in the same way that the other one did. It didn't reduce and leave x alone. It didn't reduce and leave y alone. This means there's not one solution. It means one of two things. Remember, in our linear equations, we either have one solution, we have no solutions, or we have infinitely many solutions. So if you see that that whole row goes away like that, then you're going to know that it has infinitely many solutions. Okay, it means that the equation basically was a repeat of the other one. One of them disappeared. It means that they're both the same. They both have the same slope and intercept and all that. So we see that this one has infinitely many solutions. So if I show answer over here, infinite number of solutions. Okay, so let's try another one. Let's skip ahead here. All right, let's pull the calculator back out. Now, like I was saying before, I wanted to run through again to show how to enter this, like with all the steps again. But now, an easy way to enter another one. So again, I have 2 rows and 3 columns, so I could use this again and replace these numbers if I just bring it back up again. So I'm going to hit second and then enter. That's going to re-enter the same matrix. And now I can use my calculator. I'm going to hit the arrow key over here, and I'm going to go highlight my numbers again, and I'm going to change them. So I can make sure that your cursor is in front of the number if you want to replace it, or on top of it, sorry. So my numbers here are going to be 2, -6, negative, I'm going to change the 7 to a 6, and then I've got a 12, and then my bottom row, just going to save yourself some time by re-entering it, and I'm just putting these numbers over it. I'll delete the negative, I've got a 1, a 7, and I've got a negative 14. So let's delete, okay, 14. And now I can go ahead and just hit enter. Alright, so again, it gave me the 1s and the 0s, 1 in the x place, and then the 0 is 1 in the y place. So this looks like x equals 0 and y equals -2. So it has one solution. So let's grab again here. X equals 0, y equals -2. Okay. So let's try another one. Skip ahead to number 4. Let's actually skip to number 5. Let's try this one. So I'm going to do the same thing again. I'm going to hit the second key and then enter, and that's going to bring up my same one, the same matrix as last time, and I'm going to replace the numbers with these ones. So -2, -7, -12. So let's get in front of it. So -2, -7, what was it, -12? -12. -12, and then my bottom row should be 8, 28, 24, 8, 28, and 24. And then just hit enter. And it didn't like that, so let's see, I probably just had that cursor still in there maybe. Oh, I did the wrong negative. Should have been that negative. So let's go ahead and hit enter again. Alright, so notice on this one, it again did not just give me an x equals and a y equals. It didn't clear the other variable and give me an answer here. But this last row is not all zeros, right? It is 0, 0, 1. So because of this, because that last row didn't go all to 0, I know that this one doesn't have one solution because it didn't tell me x equals and y equals, right? But this one will have no solution. So if you get that whole row of zeros, you'll have infinitely many solutions. If you get just 2 rows that won't reduce, that means there's no solution. Okay, let's just write that. So this one has no solution. Alright, so let's go ahead and look at a story problem. So Brenda's school is selling tickets to the annual dance competition. competition. On the first day of ticket sales, the school sold 5 senior citizen tickets. So let's call X the senior citizen tickets, and 4 student tickets for the total of $88. So let's call Y student tickets. The school took in $200 on the second day by selling 10 senior citizen tickets and 10 student tickets. What is the price each of 1 senior citizen ticket and 1 student ticket? So it looks like we have the first day they sold 5 senior tickets. So this is the cost of the senior ticket, and this is the cost of the student ticket. So if they sold 5 tickets, we would multiply that by 5 senior tickets. We'd multiply that by the cost to get the total amount of money they took in, and then we would add that to the 4 student tickets, and we would times that by the cost of each student ticket. That total was $88 for day 1. On the second day, they took in $200, and they sold 10 senior tickets, so 10 times X. And they also sold 10 students tickets, so 10 times Y. So here's our system. We're going to go ahead and put this into our calculator. So we've got, okay, so we have, let's just again do Y in a second, and then enter, and that's going to bring up our matrix. And place these numbers to match our problem. Alright, and I think somehow I got erased. So let's look at it again. Yeah, 5. And then 4 student tickets. And for a total of 88. And then the second day we've got 10 of each. For a total of 200. So 10, 10, and 200. Just go ahead and hit enter, and it looks like X is equal to 8 and Y is equal to 12. So that means that a senior citizen ticket costs $8. So X equals 8. Well, that is working great. So a senior citizen ticket costs $8 and a student ticket costs $12. Okay. All right, so now we're going to quickly look at an example where we have more than 2 equations and we also have 3 variables. So again, we don't have to do this by hand. We are going to use our calculator. So let's go ahead and enter this in. First of all, make sure your X's, your Y's, X's are all first, Y's are all second, Z's are all third, and then we have our other number. Any extra numbers in the equation that don't have a variable are across the equal sign. So we got to make sure that we have each equation in that form before we begin. And since it looks like we're okay, let's go ahead and we will enter this in. So I'm going to hit second math. Sorry, no, that's not what I wanted. I'm going to hit second, and then I'm going to hit matrix. I'm going to go over to the math inside matrix category. I'm going to go down, and I'm going to highlight our area. If you could just hit B, and that would give it to you. I'm going to hit enter, and then I'm going to enter my matrix by hitting alpha and zoom. And this time I have 3 rows and 4 columns. So I'll need to put in a 3 by 4. So highlight 3, hit enter, 4, hit enter, and then go down and highlight OK and hit enter. And that's going to give us our 3 by 4 matrix. So the first one would be -3, -5, -1, -3, -5, -5, -1, and then -3. Oops, I got 2 negatives there somehow. Negative one rows. So -3, -5, -1, and then -3. Second row would be 4, and then 3, and then -4, 0. And my last row would be -5, -5, -3, and 11. So just enter those in, hit enter. Alright, so I do like that I see 1 on the diagonal here and all these others simplified to 0. This means there's one solution. Since x is my first variable in that first column, and that's where the 1 is here, I know that x is -5, y is 4, and z is -2. Okay? So you can go ahead and write that down. X is -5, y is 4, and z is -2. Okay? Wherever the 1 is, whichever column the 1 is in, is going to tell you what the variable is. Is it x, y, or z? And then if one of the, or if not all of them simplified, and it doesn't have that 1 on the diagonal, there's either infinite solutions or there's no solution. If there are infinite solutions, both of these will all go to zeros. If there's one solution, at least one of them may go to 0, the other one won't, and it won't have those 1 on the diagonal. Okay. All right, so let's just go ahead and see what other examples we have. Okay, this one, notice there's no z term, so you would put a 0 where the z is. Same here, there's no a term, so you put 0 where the a is. I just wanted to see if there's any there. So it looks like we're okay. Let's just try this one. We'll do this last one together. Okay. So again, because I did a 3x4 matrix last time, I am just going to pull up the old one and enter new numbers. So I hit the second enter. I'm going to use my arrow key, get over here, and place this number. So I'll need a 6. So 6 and 2 and -4. Oops. Let's try that again. So 6 and 2 and -4, and then it equals -16. And then notice my x term is missing here, so I put a 0 where x is, and then a 2, and then a 1, and -3. And then on my third row, I got -6, -5, -1, and 24. Oops, not 214. That, there we go, and then hit enter, and let's look at what we got. Again, we have the 1s on the diagonal, which means there's one solution. X is -3, y equals -1, and z equals -1. Alright guys, so go ahead and give some of these a try. Let me know if you have questions, and have a great day.